Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science, MLR Institute of Technology, Hyderabad. I welcome you all with another video on the subject stream processing and analytics. Okay, in the previous video, we have discussed about the introduction of the subject and what does it mean. Okay, in this section, we are going to discuss how stream processing works and what are the real-time applications. We'll look into it. So let's move on to the overview. Let me give you a quick overview of today's presentation. In this overview, we are going to discuss what is stream processing. As a second part, how does stream processing works? In the next step, we are going to learn stream processing use cases. And finally, I'll discuss about what are the challenges in working with streaming data. Okay, so now let's move on to the first topic. What is stream processing? Okay, as we have discussed in the previous lecture, stream processing is a technique of data processing. Okay, as I have told you that it is nothing but a data processing technique. Okay, and management, not only processing as well as the management. Okay, which uses a continuous data stream, analyze, transform, filter and enhances it in real time. Okay, what is a stream? As we have discussed in the previous lecture, stream is nothing but continuous flow, right? If we combine this with the data as data stream, this indicates that data is in continuous form. Okay, there is no break. As data is generated continuously, that data, if we collect, that is going to analyze, transform and filter in real world scenarios. Okay, once processed, the data is sent to another application. What does it mean here? Once the continuous data is analyzed, transformed and filtered, that data or that insight or that output we can send it to an application. Suppose here there are two types of devices, if we can say. So here we have collected the data and processed already. Okay, let us consider this is a processed data. Okay, already we have got the insights. So these insights may be sent to another application or that may be stored on any storage devices. Okay, not only sent to another application, as well as we can store on another storage devices. Okay, or another streaming processing system, or that can be sent to another stream processing engine or stream processing systems. Okay, there is a chance of collecting that data in a multiple ways, not only storing on one particular device. There may be chances of storing the insight on multiple devices. Okay, stream processing engine enable timely decision making. What does it mean? Okay, as the data generated and passed into the system, immediately we are getting the proper decision making based on the time, based on the situation, we are getting the proper insights. Provides insights as data flows in. Okay, once the data is collected in a continuous form, that data is going to get the proper decision and making them crucial for modern data driven applications. There are multiple types of application in the real world. Few applications are data driven, which means that the entire application requires the immediate insights based on the data in that particular application. So for that kind of situations, the stream processing technique can help them to get the proper insights. Now let's move on to the next slide. How does data processing works? Okay, this is the workflow of data processing. Okay, in the real world scenario by using the stream processing technology. Okay, here in this workflow there are multiple steps. We'll discuss one by one in detail. Okay, the first step in stream processing workflow is nothing but data collection. Okay, as we know that if you process anything or any application or any project, first is research part, right? So as a research part here, the first thing what we have to do is we have to collect the data. From where we have to collect the data? Here, as I have told you, that data is continuously collected. Okay, from various sources like sensors, social media and financial transactions. From where we can get this kind of continuous data, in the sense sensors. Okay, as already you know that sensor is a continuous data generating systems, right? And social media as well. Social media is a digitalized, right? So millions of people are using social media, so they will generate the data per second. And financial transactions in banking sector also, customers make a multiple transactions per second. So that kind of continuous data we can collect. The second thing is that once the data is collected, the data is ingested into the stream processing engine. Here, what does it mean? So if you just look at this example here, data processing is 3 steps in stream processing. Okay, the first thing is that data collection. Okay, to process any data, we have to collect the data, right? So here we can collect the data from multiple sources, as we have discussed, sensor, social media, or financial transactions, and that continuous data is immediately ingested into the next stream processing engine. Okay, stream processing engine, it will process the data, and it will provide the insights as a output to the output devices. Okay, output devices, as we have discussed in the previous slide, output device may be one storage or one application or another stream processing engine. Not only it is fixed to one particular device, we can store it on any other devices. Okay, so as a mediator of input and output, there is a engine that can get the output, that can helpful to get the output. Okay, the incoming data is ingested into the stream processing engine without waiting to accumulate the large batches. Okay, instead of making batch wise, here this is one batch, this is another batch, this is another batch, it will send the entire batches as one data. Okay, not only it will not create batch wise, it will not create batch wise, it will continuously ingest the data into the stream processing engine. Okay, then that ingested data will process in real time. Okay, so the third step is real time processing. Each piece of data is immediately analyzed. Okay, as we are dealing with the real time data, that data is immediately analyzed and processed as it arrives. Okay, once the data is arrived into the input data storage, immediately we can get the insight, or it will give the output. And the fourth step is data transformation. Okay, data can be found in multiple forms, right? Not only one particular form, we can find multiple ways, right? So the engine may transform the data, such as filtering the data, aggregating with some functions, or enriching it with additional information. As the data we are getting from the real-time processing, that data may be there may be chances of filtering it or aggregating, or we can add some information, additional information which is necessary for that data. Okay, we can add that as well. Next, after adding some additional information, the next step is immediate insights. Once the data is enhanced with the necessary information, the data is immediately collected, and the processed data provides real-time insights and results. Okay, the processed data may provide real-time insights. After that, instant actions. Okay, once the data is collected, the processed data, that will give you the instant action. Based on the insights which we have collected from the previous step, the system can trigger instant actions. Suppose if there is a necessity of acting on the timely basis, that can be triggered from this step, or responses, ensuring timely decision making. This is nothing but we are responding based on the time, based on the situations, or based on the circumstances. Immediately we are giving the actions. Okay, then last step is finally we can get the output. Okay, the results are outputted to various destinations. As I have told you in the previous slide, the results are, we can not only restricted to one particular destination, we have multiple destinations as dashboards or any reports or databases. We can collect the output on any databases or any alert systems, which means that the alert systems works based on the time for further use or analysis. That data can be used for further use or for further analysis. Now, all the steps involves the workflow of stream processing. Now, we'll move on to the next slide. So here I have given a small, picture representation of. Okay, here I have given a small representation of how data processing works. Okay, if you observe that data is collected continuously as an input, and immediately the data is ingested into the stream processing engine, which is a main important thing in our data processing, and that immediate insights or output are stored on any other devices. Okay, this is a simple presentation. Okay, now let's move on to the next topic. Okay, here in the third slide we are going to discuss what are the use cases stream processing has. Use cases are nothing but we can tell as a applications. Okay, where the stream processing where the stream processing technology is implementing in the real world. Okay, so we'll discuss one by one now. First thing is that fraud detection, where we can see this kind of detection, this kind of scenario means in banking sector, right? So there may be chances of fraud in financial transactions. Okay, yes or no? Financial transactions, because per second, for 1 second, there are millions of transactions are happening, right? So in that millions of transactions, finding out some one fraud transaction is very challenging. So with this technology, stream processing technology, we can find out, by collecting the continuous transaction details, we can find out that one fraud transaction. This is mainly using for that purpose. Okay, so and the next application is managing location data. Okay, as all of you know that there are Google Maps, right? So for if we discuss as an example, Uber, Ola, if you apply this kind of technology on these particular applications, we can find the location details, right? Per every second or for every minute where the device is or where the vehicle is, we can find out, right? So for that kind of data also we can apply this stream processing technology. Next, personalizing customer experiences. Okay, so as customer feels satisfaction, then only any customer can use that the service or any application. So for personalizing means here we are recommending the related customer searches. Okay, we can recommend and we can give the suggestions as well by using this stream processing technology. Okay, next, stock market trading. As all of you know that stock market plays a key role in Indian economy, right? So we can predict, we can predict the stock rates on, we can collect the continuous data and immediately we can, get the insights based on the, running data. Analyzing and responding to IT infrastructure events. Okay, analyzing IT related sectors or IT related infrastructure and responding to immediate questions or immediate queries, infrastructure events. Okay, next, digital experience monitoring. Here digital experience in the sense we can take social media as an example. Okay, if we take social media an example, here everyone are using social media, right? So monetizing their behavior, customer behavior. Okay, customer behavior, how which kind of application they are using, or they are in which application they are mostly using for any other related or any other fun or any other financial related or any other things. We can monitor those kind of digital experiences. Customer journey mapping. Here customer journey mapping in the sense the journeys of if let us take a bus journey or any other journeys. Okay, we can by continuously where the vehicle, we can find out the destination place of any vehicle in a journey process. And the last thing is that predictive analytics. Okay, mainly this kind of analytics we can find in business, right? So predicting the business models and predicting the business scenarios, we can apply stream processing technology so that we can get the there is a chance of profits in a business related scenarios. Okay, now let's move on to the next topic. So here the main important concept of stream processing is nothing but as the data we are collecting continuously, so some challenges we can face with dealing with the streaming data, because data is not a static or we are not storing on any devices. Here when we are collecting the data as it arrives, right? When it is generated, automatically the generated data is converted as a insight. So there are some challenges we face while dealing with the streaming data. So here, streaming data architecture requires special considerations. Why? Because as data is continuous, we have to show some considerations due to the nature and volume of data. As you know that there is a huge volume of data generating day and night, right? So, and the nature of the data as well. Nature is nothing but how much data is generating, how, and the type of the data, or how much speed the data is generating. So by keeping all these considerations, we have to be careful and we have to plan accordingly. Okay, and some special considerations we have to show on, collecting the data. The main challenges we face while dealing with the streaming data is nothing but, the first one is availability. Okay, the availability of streaming data. Okay, streaming data applications require consistency, low latency, and high availability. As consistency in the sense, the data which has to be collected continuously in a consistent manner. Okay, and second thing is that low latency. Okay, as the data is generating, there may be chances of latency, right, based on some system failures or any other input producer or consumer latency. There may be chances of latency, right? So we have to we have to do some plannings in availability of the data. And high availability, if the data is continuously flowing, so high availability also we have to ensure, right? So consumers are constantly taking new data from the stream to process it, yes or no? So here, consumers, as a consumer, they are consuming the data from new, right? New data is accumulating through a pipeline for processing it. So delays from the producer could back up the system and cause errors. So if there is a consumer and producer, right? So consumer has to get the data and producer has to produce the data. Okay, producer, if you take producer and consumer, producer has to produce the data continuously without any latency or consistency. Okay, and the high availability of data is also we have to take special planning, right? Okay, as a second challenge, scalability. Okay, scalability is nothing but raw data streams can surge rapidly and unexpectedly. Okay, as the data is continuously flowing and that raw data is rapidly or unexpectedly can be come in a streaming processing system. So for example, social media post spike during a big sporting event. Okay, in any IPL or cricket related events, suddenly there may be chances of views in a for a particular TV channel. If you take particular TV channel in IPL season, in a cricket events, this in this scenario, there may be chances of views of this particular channel, right? So collecting that kind of unexpected or rapid data is the challenging, right? So therefore, the system should prioritize proper data sequences. In that scenarios, the system has to prioritize which is necessary data, which is unnecessary data, and based on the sequencing, data continuous sequencing, the availability, consistency, even during peak loads. So based on the sequencing and availability, the systems has to store the data in a proper way, which is unexpectedly or rapidly coming inside the systems. Okay, that is a second challenge. In the third challenge, durability. Okay, durability is nothing but the time sensitivity of data. Data stream processing system has to be fault tolerant. Okay, once the data is collected, the data has to be stored properly based on the time. Otherwise, the data will be lost forever in an outrage or failure. Once the data is collected, the data has to be saved, right? So, stream processing systems has a fault tolerant feature, which means that the data is collected, the data is the data is again we can get as a duplication. Okay, that is nothing but fault tolerant. This automatic fault tolerance feature can make the stream processing engine a very important thing in a choosing in a real-time applications. Okay, all these things are challenges we face when dealing with the streaming data. Okay, so now we'll discuss what we have learned in this particular session. Real-time data analysis and decision making require stream processing and analytics in diverse industries, including finance, as we have discussed in the previous session, finance related transactions, healthcare for immediate insights based on the patient's data, and e-commerce as well. E-commerce in the sense, how many in e-commerce field, how many customers are purchasing one particular product based on their demand. We can analyze that kind of e-commerce transactions as well. Organizations can improve operational efficiency, customer satisfaction, revenue growth by processing data in real time. Okay, how data stream can help in organizations means they can improve their efficiency, operational efficiency, and customer satisfaction. If they provide immediate insights, the number of customers also increases, right? And they are also get the satisfaction, right? For as a customer and as a service provider, organizations can also have the satisfaction, and revenue growth by processing data in real time. And the businesses can get the revenues as well by processing this kind of real time scenarios to the customers. That brings to the end of my presentation. Thank you so much for your time and attention. Thank you.